According to the National Electrical Code, electrical installations must meet specific grounding requirements. These requirements state that the grounding electrode system must be connected to all non-current carrying metal parts of the electrical system, including transformer enclosures. Furthermore, the neutral of a transformer may be grounded at the neutral point, but it must also be bonded to the grounding electrode system. Let's consider an installed grounding system where the transformer enclosure is grounded via the grounding conductor connected to the primary cable shields. The transformer neutral is connected to a ground rod, and the transformer enclosure is also connected to the ground rod via another lug in the secondary section. Based on this information, the installed grounding system appears to be National Electrical Code compliant. Firstly, the transformer enclosure is grounded via the primary cable shields, which is an acceptable method. Secondly, the neutral is connected to a ground rod, meeting the requirement for grounding the neutral point. Thirdly, the transformer enclosure is bonded to the grounding electrode system via a separate connection to the ground rod, ensuring that all non-current carrying metal parts are grounded. In conclusion, based on the available information, the installed grounding system for the pad-mounted transformer appears to meet the requirements of the National Electrical Code. However, it is always recommended to consult with a qualified electrician for a thorough inspection and verification of the installation to ensure complete compliance and safety. This includes verifying the size of the grounding conductors and the proper installation of the ground rod, as well as confirming that all connections are tight and free of corrosion. It is also important to ensure that the grounding system is properly maintained over time to prevent any potential issues. Furthermore, understanding the specific requirements of the National Electrical Code regarding grounding can help to prevent electrical hazards and ensure the safe and reliable operation of electrical equipment. The NEC provides detailed guidelines on conductor sizing, grounding electrode selection, and bonding techniques, all of which are critical for a safe and effective grounding system. Therefore, a thorough understanding of the NEC requirements is essential for anyone involved in the design, installation, or maintenance of electrical systems. It is also important to stay up to date with any changes or updates to the NEC, as the code is revised on a regular basis to reflect the latest advancements in electrical safety and technology. By following the guidelines and recommendations of the NEC, electrical professionals can help to ensure that electrical systems are installed and maintained in a safe and reliable manner, protecting both people and property from the hazards of electricity. In addition to the specific requirements for grounding pad-mounted transformers, the NEC also provides general guidelines for grounding all types of electrical equipment. These guidelines cover topics such as the selection and installation of grounding electrodes, the sizing of grounding conductors, and the bonding of non-current carrying metal parts. By following these guidelines, electrical professionals can help to ensure that all electrical equipment is properly grounded, reducing the risk of electrical shock and fire. Grounding is a critical aspect of electrical safety, and it is essential to have a thorough understanding of the NEC requirements in order to design, install, and maintain safe and reliable electrical systems. The primary purpose of grounding is to provide a low impedance path for fault current to return to the source, allowing overcurrent protective devices to quickly and effectively clear the fault. This helps to prevent electrical shock and fire, as well as damage to electrical equipment. In addition to providing a path for fault current, grounding also helps to stabilize voltage and reduce electrical noise, improving the overall performance of electrical systems. There are several different types of grounding systems, each with its own advantages and disadvantages. The most common types of grounding systems include grounded, ungrounded, and impedance-grounded systems. Grounded systems are typically used in residential and commercial applications, while ungrounded and impedance-grounded systems are more commonly used in industrial applications. The selection of the appropriate grounding system depends on several factors, including the type of equipment being grounded, the voltage level of the system, and the specific safety requirements of the installation. It is important to carefully consider all of these factors when selecting a grounding system to ensure that it provides adequate protection against electrical hazards. In addition to selecting the appropriate grounding system, It is also important to ensure that the grounding system is properly installed and maintained. This includes using the correct size and type of grounding conductors, properly installing grounding electrodes, and regularly inspecting the grounding system for signs of damage or corrosion. A properly installed and maintained grounding system is essential for ensuring the safety and reliability of electrical systems. One of the most important components of a grounding system is the grounding electrode. The grounding electrode is a conductor that is buried in the earth and provides a direct connection to ground. There are several different types of grounding electrodes, including ground rods, ground plates, and concrete encased electrodes. The selection of the appropriate grounding electrode depends on several factors, including the soil conditions, the size of the grounding system, and the specific requirements of the installation. Ground rods are the most common type of grounding electrode, and they are typically used in residential and commercial applications. Ground plates are larger than ground rods and are typically used in industrial applications where a lower impedance connection to ground is required. Concrete encased electrodes are typically used in new construction and are embedded in the concrete foundation of the building. The grounding electrode must be properly installed in order to provide an effective connection to ground. This includes driving the grounding electrode deep enough into the earth to reach moist soil, and ensuring that the connection between the grounding electrode and the grounding conductor is tight and corrosion resistant. A properly installed grounding electrode is essential for ensuring the safety and reliability of electrical systems. Another important component of a grounding system is the grounding conductor. The grounding conductor is a conductor that connects the non-current carrying metal parts of electrical equipment to the grounding electrode. The grounding conductor must be sized appropriately to carry the maximum fault current that could occur in the system. The size of the grounding conductor is typically determined by the size of the overcurrent protective device that protects the circuit. The grounding conductor must also be properly installed to ensure a low impedance path for fault current to return to the source. This includes using the correct type of connectors, properly terminating the grounding conductor at both ends, and avoiding sharp bends or kinks in the grounding conductor. A properly installed grounding conductor is essential for ensuring the safety and reliability of electrical systems. In addition to grounding the non-current carrying metal parts of electrical equipment, it is also important to bond these parts together. Bonding is the process of connecting all of the non-current carrying metal parts of electrical equipment together to create a common ground potential. Bonding helps to reduce the risk of electrical shock by ensuring that all of the metal parts are at the same voltage potential. Bonding is typically accomplished by using bonding jumpers, which are short lengths of conductor that connect the metal parts together. Bonding jumpers must be sized appropriately to carry the maximum fault current that could occur in the system. Bonding jumpers must also be properly installed to ensure a low impedance path for fault current to return to the source. A properly bonded electrical system is essential for ensuring the safety and reliability of electrical systems. Regular inspection and maintenance of the grounding system are also essential for ensuring its continued effectiveness. Grounding systems can degrade over time due to corrosion, physical damage, or changes in soil conditions. Regular inspection can help to identify potential problems before they become serious. Maintenance activities such as tightening connections, replacing corroded components, and testing the grounding system can help to ensure that the grounding system continues to provide adequate protection against electrical hazards. The frequency of inspection and maintenance will depend on the specific environment in which the grounding system is installed. In harsh environments, such as those with high levels of moisture or corrosive chemicals, more frequent inspection and maintenance may be required. It is important to keep records of all inspections and maintenance activities to track the performance of the grounding system over time. These records can be used to identify trends and predict future problems. By following a regular inspection and maintenance program, you can help to ensure that your grounding system continues to provide adequate protection against electrical hazards. Proper grounding is not just a matter of compliance with the National Electrical Code, it is also a matter of safety. A properly grounded electrical system can help to protect people from electrical shock and fire, and it can also help to protect electrical equipment from damage. Investing in a properly designed, installed, and maintained grounding system is a smart investment in safety and reliability. If you are not familiar with the requirements of the National Electrical Code, it is important to consult with a qualified electrician. A qualified electrician can help you to design, install, and maintain a grounding system that meets your specific needs and requirements. Do not attempt to work on electrical systems unless you are properly trained and qualified. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock and fire. By following the guidelines and recommendations outlined in this discussion, you can help to ensure that your electrical systems are properly grounded and that you are protected from the hazards of electricity. Remember to always consult with a qualified electrician for any electrical work, and never attempt to work on electrical systems unless you are properly trained and qualified. Safety should always be your top priority when working with electricity. A properly installed and maintained grounding system is a critical component of a safe and reliable electrical system. Take the time to understand the requirements of the National Electrical Code, and always consult with a qualified electrician for any electrical work. By following these guidelines, you can help to protect yourself, your family, and your property from the hazards of electricity.